Welcome to Math with Mrs. Bibb. Today we will be sketching graphs and comparing functions, graphing linear equations, and inequalities. First, we will talk about the key features of a graph. You'll use these key features to graph functions and compare functions. If you will please write down what I write down as we go along. The domain tells you how far left or right a graph goes. The range tells you how far up or down. A graph goes. Please be sure to write this down. And the intercepts tell you where the graph crosses or touches the x-axis. Or y-axis, I should say, as well. The end behavior literally tells you how the ends are behaving. Whether they go up or down. If it's up, you'll see positive infinity. If it's down, you'll see negative infinity. Next is the extrema. Extrema tells you the high or low points. They're also called turning points. It's where your graph is increasing or decreasing. So increasing, going up, decreasing, coming back down. That graph, this would be considered an extrema. And then if your graph continues, then it would be decreasing on the left and then increasing back up on the right. These are your extrema or your turning points where that graph is changing direction. And next, the increasing, decreasing. Well, I think I skipped symmetry. Oops. I'll go back and get the symmetry. I missed it right there, but that's okay. I'll go back and grab it in just a second. And for the increasing, decreasing, the graph itself is going up or down based on what x is doing. Let me go back and grab the the symmetry, sorry. So this one is about symmetry. Please write it down by symmetry. So symmetry. It says where the graph is a reflection or a rotation of the other side. So if it's a reflection, it's that line symmetry that we discussed. For example, a graph like this would have line symmetry because this line here, the y-axis, cuts it in half. So that's line symmetry. And then when you think about point symmetry, you can pick a point on that graph and you can rotate it 180 degrees and you will find a point on that graph that's on the same spot. You can rotate that whole graph and you're still going to have the same graph. I hope that makes sense. And positive, negative. that last thing for positive, negative. When you are looking at that, it is telling you about where the graph is based on the x-axis, above or below. I'm not going to write anything for that. So next we have graphs that we want to create. So we are going to graph 0, negative 70. I am going to get rid of these numbers here. So I'm going to get rid of these numbers and these numbers. I need 0, negative 70 for my y-axis, so I don't need to go by the values that are there. So 0, negative 70, if I were to plot that point, I'm just going to say it's here. 0, negative 70, that's my y-intercept. It's a line because it says it's linear. Next it says it's positive for all values of x such that x is less than negative 30. So my line is going to go, my line, yes, because it's linear, is going to be below negative 30. So if negative 30, let me do it in green. If negative 30 is here, then it's going to be below negative 30. And then that end behavior definitely helps me decide. It says as x approaches positive infinity, y approaches negative infinity. So the end is going to be down here. As x approaches negative infinity, y approaches positive infinity. So the end will be up here. So I'm going to draw a sketch. It's not a beautiful sketch, but I'm going to draw a sketch of the line that fits that description. For number 2, I'm going to leave my values there. For number 2, the y-intercept is 0, 3. So 0, 1, 2, 3. There's my y-intercept. It says it's not linear, so it's not going to be linear. I'm not going to draw a line. It's a continuous curve. It's positive for all values of x, so it's positive for all values of x. It's decreasing. X is less than 0, so it's decreasing. From the left, it's coming down. And then extreme minimum is 0, 3. So that's the lowest point of this graph being extrema. It's a minimum value. And then the end behavior. As x approaches positive infinity, so does the y value. As x approaches negative infinity, so does the y value. So I'm going to draw a parabola through 0, 3, and that would fit all of those descriptions mentioned in the instructions. For number 3, we're going to talk about Hay test driving a car that she's thinking about buying. She wants to accelerate that car to 60 miles per hour and then decelerate it to see how quick it can accelerate and how good the brakes are. So it takes her 15 seconds to reach her maximum speed, and then 15 additional seconds to come to a stop. So we're going to use key features to draw that graph. And if you notice, my x and y axis are not at points that I need, so I'm getting rid of those. So hopefully you will as well. I'm going to fix it with values that I can use. My x is time, so that's the seconds. So I'm going to go by 3s on my x-axis, and my y is the miles per hour. So I'm just going to go by 6s on my y-axis, 3 on the x and 6s on the y. So I'm going to go 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Then I'm going to go by 6s on the y, 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. And I'm going to graph, of course we should start at 0 miles per hour, because when she starts to test drive a car, she's not driving any length of time. So time is my x-axis, and she's not going any speed. So my speed is my y-axis. Okay. So starting at 0, 0, and then she accelerates to 60 miles per hour in 15 seconds. So I'm going to count over to 15 and up to 60 and put a dot right there. So over to 15, up to 60, and put a dot. And then she decelerates back to a stop, which would be at 0 miles per hour in another 15 seconds. So that would get me to 30. So accelerate and then decelerate and stop. That would be the graph for number 3. Number 4, we're going to use the table and the graph to compare the functions. Let's look at intercepts is the first thing that my mind and my eye is drawn to. So as I look at this, for the table, my x-intercept, that's where y is 0, is 3, and my y-intercept is -1. And as I look at the graph, my x-intercept is 1, 2, 3, 4. My x-intercept is 4, and my y-intercept is -2. I can't really tell much about the ordered pairs unless I plot them, but I can compare these two answers. On this graph, if you would put the x-intercept of 3 here, then we can say that f of x intersects the x-axis, intersects the x-axis at a point farther away from the origin than g of x. And please keep in mind, there are many correct answers here when you're asked to compare. Just make sure they make mathematical sense. For the next one, we're going to graph using Desmos. Hopefully my Desmos calculator will work here. So anytime it says graph using Desmos, then or using a graphing calculator, then that's what we'll do.